Very good evening, all my dear students. Welcome back again to your Unacademy NEET English channel. Hey, all my dear students, how is everyone? How is the Josh? I want to see my dear students. Am I audible and visible? Wow, that's really awesome that Betsy Samson is here, Bedha Janani is here, Subhasri is here. All my dear students, welcome. Suswagatam to each and everyone, my dear students. Suswagatam to all my dear students. I hope that you are fit and fine. And today we are going to start this fabulous chapter, that is EAR. The meaning of EAR is electrophilic addition reaction. If I talk about your NCERT corner, then I would like to say most of the portion of this reaction belongs to hydrocarbon. In a hydrocarbon, alkane, alkene and alkyne is there. Alkanes already we have completed during free radical substitution reaction. Now alkene and alkyne, they have got double bond. That double bond makes them to be the nucleophilic in nature, my dear students. So all alkenes, alkadies and alkynes are nucleophiles, and definitely they would like to go electrophilic addition reaction. Even benzene also, 10% I can say that benzene wants to undergo electrophilic addition reaction. Rest 90% it would like to show electrophilic substitution reaction, because that is being aromatic. Vanakkam, Shiva Ranjani G, Siddharth, Anish is there. Oh, Vanakkam, Anish is there. Buddha Surya is there. Krishna is there. Srinath is there. Oh, my dear students, lovely. But what I can see, my dear students, likes are less. Everyone try to mark your attendance. What are you doing, my dear students? Samriya is there. Hema is there. Hi, welcome to each and every one of you. But kids, hit or smash the like button so I can see your attendance, that everyone is over there. What I can see right now, the likes, yeah, they got increased. Now that's fantastic. So without taking too much time, my dear students, I would like to say that let's start it. And this is your HSP Baba. I have been teaching from, you can say, for the last 24 years. Yes, both the IIT as well as NEET students produce number of ranks 1, 2, 3 like that, and mass selection. My dear friends, it's all your hard work. If you're really doing hard work, selection and your good marks are waiting over there. So those who are new, subscribe this lovely channel. This is yours channel. And my regular dear students, everyone, don't forget to hit the like button before I'm going to start this awesome, big and most important chapter, that is electrophilic addition reaction. Happy Vinay Chaturthi to you, Jyoti. Oh, Jyoti is also there. So my dear students, let's start it. And I think this electrophilic addition reaction should come over there at the top, because it was written at the last. So let me make it come at the top level at the starting. So let me arrange this page. Okay, it should be over here, and I kept it over there. Now let's start. Now my dear friends, in the examination, no one will be there to tell you what type of reaction you are supposed to do. So what you are going to see in the examination, because you know that in between you and paper, everything will be blank if you're not having these preparations from the starting. Let me tell you, in this chapter, I will let you know addition of HX, X2, HOX and water, that is OMDM reaction, HBO reaction and Markovnikov's rule. All these are the important things which holds a lot of weightage. Now my dear students, see what you are going to see in the examination which would remind you about to think about such type of reactions. This is ethene, this is butadiene. I'm not saying that particular these type of reactants only you are going to get. In place of this ethylene, you can get any alkene. Any alkene would do the same thing which the ethene is going to do. Any alkadiene will do the same thing as this alkadiene is going to do, my dear students. And the third one is ethine, because these three things, they are really very important, because they are given in NCERT, and the same will do any alkyne. So how to find out in the examination that these compounds are going to give the electrophilic addition reaction? Just see what they are having. They are having this pi electron. Everyone, before I'm going to tell you, it's your duty. You have to write down in the chat box what I'm telling you, kids. What I'm telling you. And simultaneously, I'm watching this chat section also. Whatever I'm going to tell you over here, if you know, if you can answer it, it's your duty. Buddha Saudia, I will let you know each and everything. Don't worry, I will let you know each and everything. So it's your duty. You have to tell me what I'm telling you. All they are having pi electron, and because of these pi electrons, because of the pi electrons, they are rich. They are rich in electrons. They are rich in electron. According to your HSP Baba treats electron like money. So they are rich in electron. Let me enclose this in the box. This is very important thing. They are rich in electron. So I would like to say they are rich people. They are rich. So they are nucleophilic in nature. I would like to say they are, all these entities are being nucleophiles. Means all the entities which I have written over here, all these are being what? These are being nucleophiles. These are being nucleophiles. So my dear students, what do you think? These nucleophiles will attract towards stem cell, the nucleophiles or the electrophiles? You know, honeybee gets attracted towards nectar. Nectar is not going to get attracted towards nectar. Honeybee is not going to attract towards honeybee. That if some reducing agent is there, that will get attracted towards oxidizing agent, and if some oxidizing agent is there, so it must get, so these attracts, these nucleophiles will attract whom, kids? Do let me know these nucleophiles in the chat section. Everyone, do let me know these nucleophiles will attract whom. They will say, hey, come on, Ingeva, come over here. Ingeva means come over here. So whom they are calling? They are calling to electrophiles. The electrophiles will get attracted towards themselves, not toward themselves, toward these people, because they are electron deficient and these are electron efficient. This is the thing which you have to recognize in the examination, which you have to think about the examination. So remember one thing in your brain, whenever you see such type of entities, hey, you are electron rich. So remember that. What type of reaction? In the chat section, write down what type of reaction they will go. what type of reaction they will go? Yes, they will say, I will say they will go electrophilic addition reaction. Now, my dear students, see. If I write any alkene, so first of all, let me categorize. Right now, I'm going to tell you about electrophilic addition reaction, that is addition of HX. First reaction is addition of HX. Addition of HX. Addition of HX. Addition of HX. See, this is the technology. See, what I have written got changed. So addition of HX. This I'm going to tell you first of all. What is HX? You know, X is being halogen and H is H. That is addition of hydrogen halide. Hydrogen halide. Hydrogen halide. Now, my dear friends, in the elimination, that was E2 and E1, what you have seen? Dehydrohalogenation, just opposite of dehydrohalogenation. This is hydrogen halide addition, that is the addition of HF, HCl, HBr and HI. These additions we are going to deal with. Now, my dear students, for that you must be provided with some alkene. Let's suppose this alkene is RCH double bond CH2. Now, if this R is electron donating, so it will donate electron, and you can see this electron will get shifted toward this side, and here you will get delta negative, and here you will get delta positive. Is it clear? Is it clear? Kriti Verma, welcome, welcome. Now, whatever your HX is there. Now, my dear students, before telling you this reaction, you should know this H is having delta positive and this X is having delta negative, and this is being nucleophilic in nature. So, nucleophilic in nature means what is going to happen? It will attract towards delta positive or delta negative. Definitely your answer should be, it is going to attract this delta positive, and this can attack at this carbon and this can attack on this carbon. Two possibilities are there. There are being two possibilities. Thank you, Chitti Kumar. Chitti. Wow, Chitti Ganna, very good. Now, two possibilities arises over here. One is being this possibility, another one is this possibility. Now, my dear students, I'm going to write down both the two possibilities are CH, CH2 positive. If this H is going to attack at this position, and second possibility is R CH positive CH2H. My dear students, you can see two types of carbocations you got. You know that here the carbon is having 8 electrons, but their carbon is having just 6 electrons. What do you think? This carbon must be crying, oh, mommy, hey, mother, I have become electron deficient. What do you think? This compound wanna go to that side, or it doesn't want to go that side? It doesn't want to go that side because somebody has stolen its electron. It has attacked. It is being attacking agent, and the attacking agent is attacking on this electrons, and it is becoming electron deficient. Now, carbon is having just 6 electrons. This compound is saying, hey, HS, don't attack. But this HX is saying, I will attack. I will come over there. I want to attack on you, and you will become like this. So, my dear student, this is the slowest step, rate determining step. I would like to say, kids, this is being the slowest step, and rate determining step. It will lie more towards this direction and will go less towards this direction, that direction. Kids, are you getting my point? Now, slowest step Slowest step, rate determining step. Everyone, are you able to understand what I'm telling you? Slowest step, RDS. RDS. It's not RDX, it is RDS, rate determining step. Now, this carbocation is just 1 degree and this carbocation is 2 degree. Just to let me know which carbocation is more stable, upper one or the lower one. Which carbocation? Bhavya Shri, your classes are such a amazing, sir. Hats off to your such dedication, teacher, sir. We are. Thank you, kids. Thank you. Your Baba is there, always to help you, always working for giving for strength. Thank you. Thank you. 2 degree carbocation. This is more stable. My dear students, remember that the more stable carbocation, more formed. More stable, more stable, more formed, more formed, more formed, more responsible for major product, more responsible for major product, kids. Both type of products will get formed, but the more stable will be responsible for major product formation. So everyone, are you getting this point? Thank you, thank you, thank you. Got it? Anju Singh, got it? That's really awesome. Now, kids, in the second step, let's see what is going to happen. RCH plus CH2H. Now, my dear friends, the one who is going to directly add the X negative part to this, that student will get failed. Remember that. This carbocation started shouting, hey carbocation, why are you shouting? What's the problem with you? What happened to you? Carbocation is saying, think always about rearrangement before product formation. What this carbocation is saying, my dear students? This carbocation is saying, always think about rearrangement. Always think about rearrangement. Always think about rearrangement before product formation. So you know that the type of rearrangement, hydride shift, methyl shift, ring expansion. So if the rearrangement is possible, then do it, or if not possible, then add X negative to it, and that will be your first step. Add X negative to this and you will get product, my dear students, RCH CH2. Now, my dear students, one thing, the hydrogen attached over here, and this carbocation is having one lobe above the plane, another lobe below the plane, the one lobe above the plane, another lobe below the plane. So the attack of the chloride negative will be from both the side. X negative, chloride you can say X negative, above the plane and below the plane. Means if this carbon is being chiral, then two types of products you will get. Now, till now, I've told you the basic mechanism, my dear students. Now, let me give you one reaction. See, the reaction, my dear students. If the reactant provided is like propene, CH3, CH double bond CH2 plus HX, means let's add HCl. What do you think? What product you are going to get, my dear friends? First of all, add proton. Where the proton will attack? Proton will go to this carbon also, and proton will go to this carbon also, but this will be the major part and that will be the minor part. Means you are going to get two types of carbocations, my dear friends. Chitti Kumar Khanna, thank you, thank you. Now you are going to get two types of carbocations, CH3, CH positive, CH2H, and CH3, CHH, and CH2 positive, Now this will be the major one, major carbocation, and that is going to form as the minor bond. Now this step was the slowest step. The slowest step is the rate determining step that will go more towards backward direction, less towards the forward direction. Now this is going to be the first step, the chloride negative, because the rearrangement is not going to take place. Already the stable carbocation is there. So chloride negative, first step, chloride negative, first step. Now what products you are going to get, my dear students? We will get the one product like this, ClCH2H. This is your major product. Now CH3, CH2, CH2. Yes, Cl. This is your minor product. I hope that this example is clear to each and everyone. Buddha Surya, why you are leaving? What happened? Bhavani, Bhavani. Buddha Surya is saying, I'm leaving. Don't go. Don't go, Buddha Surya. Now, my dear friends, there was one scientist named as Markovnikov. Have you heard this name, my dear friends? What is the name of scientist? The name of scientist is Markovnikov's rule. My dear students, if you are in class 12th, your teacher will definitely ask you what is Markovnikov's rule. So let's see and let me explain what is this rule. This rule says that if you are provided with unsymmetrical alkene, what? Everyone say, what type of alkene? Unsymmetrical alkene. Unsymmetrical alkene plus unsymmetrical reagent. Unsymmetrical reagent, let's suppose HCl. Unsymmetrical reagent. This is unsymmetrical alkene. This is unsymmetrical reagent. Now, this rule says that negative part of the reagent will go to that double bonded carbon, means that sp2 hybridized carbon which is having less number of hydrogen atoms. Zoop, it will go to this. This is going to be the major product formation, my dear students. Oh, take care, Buddha Surya, take care, Kriti Verma, good. Now see, the product formed will be like this, CH3, CH3 and Cl. My dear students, this is the major product form. Now how will you define Markovnikov's rule? My dear students, what this rule states? Markovnikov's rule states, let me write down. Markovnikov's rule states, Markovnikov's rule states that negative part of the reagent will go to that double bonded carbon which has less number of hydrogen atoms. But remember that, my dear friends, this rule is valid only when both of them are unsymmetrical. The substrate and the attacking agent both should remain unsymmetrical, then only this is valid, otherwise this is not valid, my dear students. Whenever you are going to solve any question in your examination, let me tell you one very, very important thing, my dear students. Whenever any question is coming in your NEET examination, never follow Markovnikov's rule, because even Markovnikov got failed. Never follow Markovnikov's rule while doing question. Let me give you a disclaimer that never follow Markovnikov's rule while doing question. Now, sir, if you're talking like this, then why you have given this Markovnikov's rule? Why you have told us the Markovnikov's rule? Kids, let me tell you, if the examiner is asking what is Markovnikov's rule, then only you have to understand this mechanism, because if the examiner is focusing on what you mean by Markovnikov's rule, then you should know, you should have to have this thing in your brain, that what is the meaning of Markovnikov's rule. But if the question has been asked in the examination, never ever follow Markovnikov's rule, because only in 10% question Markovnikov's rule is going to get passed. Otherwise, whenever the Markovnikov rule is going to get failed, even you don't know. So always follow mechanism. Buddha Surya is saying, Buddha Surya, yeah, permission is granted. Buddha Surya, you take care, because you are having high fever, and take care. Buddha Surya, each and everything is, all the permissions are given to you. May Almighty God bless you with healthy your body, without fever body, get well soon. Okay. Now, kids, while solving questions, always follow mechanism. Always follow mechanism. Never follow Markovnikov's rule. Let me tell you. Here the Markovnikov's rule got passed. Let me tell you the example where Markovnikov's rule is going to get failed. See, kids, in my school time, when I was student, nobody was there to tell us this thing, and that's why we were losing our marks. But I'm telling you, kids, see, if you are provided with compound like this, and they have given you question, addition of HCl to it. Now, my dear students, the one who has crammed Markovnikov's rule, what that student is going to do, just think what that student is going to do. Definitely, he must have crammed it like this. Markovnikov's rule states that negative part of the reagent goes to that double bonded carbon. Most of the time, 90% cases, what happens, you forget about that negative part of the reagent goes to which carbon? The carbon was having more hydrogen, or the carbon was having less hydrogen. By chance, at the last, if you are able to remember, that negative part of the reagent goes to that double bonded carbon which has less number of hydrogen atoms, so you will add this negative part on this carbon, and what answer you are going to mark in your examination, you will definitely mark this option in your examination, isn't it, kids? Now, what do you think? The one who is going to mark this answer for the major product, is he going to pass or is he going to fail? That student will definitely get failed, because that is not major, that is minor. See why? Because the mechanism says the first attack will be by this proton, and this proton will attack over here, and the proton is going to attack at that carbon. So see what you are going to get. You will get this compound, this intermediate. This intermediate says what? Whenever the intermediate is formed, always think about rearrangement. This is our moral duty. Always think about rearrangement. And whenever you see this phenyl, my dear students, whenever you see this phenyl always shouts loudly that migrate somebody from here, the plus charge is going to come at this carbon, and that will get resonance stabilized, and that is going to be the most stable carbocation. So this is known as 1,2 hydride shift. 1,2 hydride shift. 1,2 hydride shift, my dear students. Are you able to get it? Just do let me know. This is most stable carbocation, and definitely the major product will be like this. This will be your major product, and my dear students, let me tell you, this is not one product. You can see this carbon is chiral, so equimolar dextro and levo will get formed, and this is your known as racemic mixture. Racemic mixture will get formed. This process is known as racemization. I hope that everyone is able to understand. Kids, do let me know till now. And here Markovnikov's got failed. Failure of Markovnikov's rule. Markovnikov's rule got failed over here, my dear student. Are you able to understand? Markov got failed. Markov got failed. Mechanism is winner. Mechanism is winner, my dear student. Who is winner? Who is winner? Mechanism is winner. Mechanism is winner. Hey everyone, do let me know that. Are you able to understand, kids? Muhammad Jaid is saying unsymmetry. It's asymmetry. Both are correct. It's desymmetry is also there. Muhammad Jaid, one more word is there. Desymmetry. Asymmetry, unsymmetry, desymmetry. Number of things are there, Jaid. Now, my dear students, if the examiner is asking this question, just see, kids. If the examiner is asking this question, arrange the following. Question is, arrange the following in decreasing order of reactivity, decreasing order of reactivity with HX. So options given are alkadine, that is butadiene, kids. Butadiene. Second option is given as ethene. Third option is given as acetylene. So could you please help me to let me know the answer? What's your answer? Everyone. Do let me know, my dear students. Yes, I'm waiting for your answer. A, B, C. Shiva Ranjani is giving answer A, B, C. Absolutely correct. Shiva Ranjani, your answer is absolutely correct. Really awesome answer given by you. Just see, everyone, why the answer is correct. Just see to it, everyone. The first attack will be done by H positive. Here what you are going to get, you will get compound like this, CH2 double bond CH positive CH2H. Now you can see this carbocation is resonance stabilized. Just see, it's doing resonance from here to here. Can you see? Stabilized by resonance, SBR, stabilized by resonance. Now if you see this carbocation, CH2 double bond CH positive, this is localized. This charge was delocalized, and CH, you can say CH, here it was CH3, kids. Here it was CH3, because H has attacked over here, and this was single bond. This was single bond, kids. CH3, CH2 plus, and here it is CH2 double bond CH plus. Now you can see this is most stable carbocation. Most stable carbocation because it is stabilized by resonance. But out of these two, how to compare? Remember that positive charge is more stable on less electronegative carbon. Now the question arises how to find out which one is less electronegative. This is sp2 hybridized and this is just sp hybridized, 3.25 electronegativity and it's 2.75. You have to remember these values. These values are really very important. So this is more electronegative carbon and positive charge is less stable on maximum electronegative carbon. Remember that positive charge is least stable on most electronegative carbon, on most electronegative atom. So this is the order for the stability of carbocation. This is the order for the stability of carbocation, and in this way the carbocations are getting formed, and this is the way the reactivity order is there. I hope that everyone is able to understand. Never make any mistake in your examination, my dear students. This is the order. Now, let me tell you the most important thing and the most important question. Now, this question really very important. If you are provided with compound like this, CH2 double bond CH double bond CH2, and in front of this Br2 is given one equivalent. So I'm going to write two types of products. You have to find out which product is more stable, because this is really very important, my dear friends. Really very important. One product is like this. First of all, let me count 1 2 3 4. This is the numbering. So one product is this CH2 Br CH double bond CH2 Br. One Br added to first carbon, another Br added to second carbon. We will say 1,4 addition product. 1,4 addition product. 1,4 addition product. Now another product is like this CH2 double bond CHBr CH2 Br. That means one Br added on first carbon and second carbon. So we will say 1,2 addition product. 1,2 addition product. My dear friends, what do you think? Which product is more stable and which product you are going to mark in the examination, the first one or the second one? Everyone, do let me know which product you are going to mark. Remember that, my dear students, remember that this double bond is at this place. You can see clearly adjacent to it there are 2 alpha hydrogen atoms, 4 alpha hydrogen atoms are there. This alkene is having 4 alpha hydrogen atoms, and this alkene, you can see adjacent to it there is only 1 alpha hydrogen atom. In this world there are two type of things, my dear friends. One is stability, one is reactivity. Whenever you are moving on the road or somebody is moving on the road, my dear student, the elder people like your father, grandfather, they will always say, hey, drive slowly. Hey, drive slowly. Even though they wanted to go, they wanted to reach at that place very fast, very immediately, very soon. But then also they will say, drive slowly, take care, move slowly, don't run. My dear students, they know that if accident is going to happen over there, you know that speed thrills, but it kills. They know very well that speed thrills, but it kills. So, speed means chemical kinetics. Chemical kinetics deals with the speed, but thermodynamics deals with the stability. And whenever the reaction is reversible, remember, do remember one point. Yeah, very good. Very good. Your answer is absolutely correct. This is thermodynamically product because this is more stable product, and more stable means thermodynamically controlled product, TCP. TCP stands for thermodynamically controlled product, and this is KCP. KCP means kinetically controlled product. Kinetically controlled product. So this reaction is being reversible, and whenever the reaction is being example of reversible, then now my dear students, you must be thinking that how this product has been formed, why the double bond, and how the double bond has shifted in between 2 and 3. How many of you are thinking like that, and how many of you want the answer of this question, that how this double bond got shifted in between this? And let me tell you, the amount of this product is 80%, and the amount of this product is just 20%. Now, my dear friends, if this question has not been given like this, if they are going to give this question that minus 40 degrees Celsius, if the same reaction is going to take place at minus 40 degrees Celsius, now see, my dear friend, if they are going to give you same reaction, CH2 double bond CH double bond CH2 plus Br2 or HBr. In place of Br2 they can give you HBr, doesn't matter. Now see kids, if they are going to give you the same reaction going to take place at minus 40 degrees Celsius, then my dear friends, this product will be minor CH2Br CH double bond CH2Br. This is once again thermodynamically controlled product, more stable, but then also it is just 20%, the minor product here. And this is 1,4 addition product, this is going to be the minor, and 1,2 addition product will be the major one. Now my dear student, number of question arises, then why and how it has happened like this, my dear students, number of questions arises, isn't it? This is going to be 80% now, this is going to form 80%. Now my dear students, how many of you are interested to understand, to know the reason behind it? How many of you are interested in knowing the reason behind it? My dear friends, do let me know that how many of you are interested that how this reaction is going to take place and what are the reasons behind it. Okay, number of students are interested. Now let me tell you, first of all, this is addition of X2. Earlier I have explained the addition of HX. Now this is the addition of X2, and there is something very interesting in addition of X2. Now see and look. My dear friends, remember that whenever any reaction is given like this, let me tell you the general mechanism first of all. The general mechanism, otherwise you won't be able to understand the chemistry. General mechanism which will work everywhere, my dear students, which will work everywhere. Now this is going to react with ENU. What is ENU? E is being the electrophilic part, Nu being the nucleophilic part, and there is one polarization, my dear students. So definitely this E plus, if this E, remember that if E have lone pair or lone pairs, or if E is mercury, what I'm saying, if E have lone pair or lone pairs, or if E is mercury, in these two conditions, remember that this is very, very important point, and this is the place where most of the students, they are going to lose marks. When if E have lone pairs or E is mercury, let me enclose it. Let me enclose it in the box. Then carbocation will never formed. Then carbocation will not be formed, my dear students. Remember that. Then carbocation will not be formed. Carbocation will not be formed. Then carbocation will not be formed. Then what is going to get formed? Then non-classical. In that case, carbocation is not going to get formed. In this case, non-classical three-membered ring intermediate will get formed. Ring intermediate will get formed. Ring intermediate will get formed. Now in this case, my dear students, ring intermediate is getting formed. Ring intermediate will get formed, my dear students. Then this is the case where rearrangement will never take place. This is the case where rearrangement will never take place, my dear student. This is the case where rearrangement will never take place. This is the case where no rearrangement will take place. Case where no rearrangement, my dear students, remember that this is the case where no rearrangement is going to take place if this E is having at least one lone pair or the E is mercury, my dear students. Remember that. Now let me explain it. That is the first reaction, addition of X2. Let me explain with the example. The first reaction, addition of X2. Now, number of times you must have seen that the hydrocarbon chapter, class 11th NCERT, whenever they are going to add Br2 CCl4, they will write like this: one Br on this side, one Br on that side. Have you seen this? That Br on opposite side, they used to write one Br on this side, one Br on that side. Have you ever seen, my dear friends? Have you ever seen in this way? Non-classical three-membered ring, I will let you know. Shiva Ranjani, don't worry, I will let you know. Shiva Kumar, I will tell you each and everything. Non-classical three-membered, what is this? I will let you know each and everything. Okay, don't worry. Now see, my dear friends, see to it, everyone, that how it is getting formed. Just see to it. Let me explain. This is your CH2 double bond CH2 Br, Br, Br. This is non-polar, this is polar. This polar compound will induce charge on this compound. You know, London forces, weak forces, Br positive, Br negative. So charge induced, and this Br is going to attack on this pi electron, and what you are going to get, see, just see, my dear students, you will get compound like this, CH2 Br, and Br is having lone pair, just see to it. And this is carbocation. What do you think? This carbocation is having just 6 electrons in the valence shell, and this bromine is having 8 electrons, and this is having lone pair. So this carbocation will snatch this electron. This electron will go to this carbon. This electron will go to this carbon. So what do you think? Its charge will decrease, and here the charge will develop, and it actually look like this. Let me tell you over here how it will actually look like. It will actually look like this. See, kids, CH2 Br plus, this is the actual intermediate. You see, this is the actual intermediate. Let me take it on the next page. Please turn over the page. Let me bring it to this page. CH2 Br positive. This is non-classical carbonium ion 3-membered ring. Just like if the carbon is having positive charge on it, we say carbonium ion. Oxygen is having positive charge on it, we will say oxonium ion. Now bromine is having positive charge, we will say bromonium ion. So this is halonium ion, this is gets halonium ion, and this halonium ion, right now it is bromonium ion. Bromonium ion gets bromonium here, and this is 3-membered highly unstable ring. 3-membered highly unstable ring, my dear friends. Highly unstable ring. This is also known as non-classical carbocation. This is also known as non-classical carbocation or carbonium ion. Now, my dear friends, see, one thing is really very important. The another bromine, the Br negative, is it possible that it can come from this side? But before attack, let me tell you, my dear friends, this bromine has developed positive charge. Now whenever it is going to withdraw electron, it will develop positive charge little bit. So this positive charge on carbon, the positive charge on carbon is not that enough so the rearrangement can take place, but it is also not very less so that it cannot attract the nucleophile. That means it is enough to attract nucleophile but not enough for the rearrangement. Just like if you are having 20 rupees, then 20 rupees are enough to eat samosa, but 20 rupees is not that enough to eat pizza. Are you getting my points? So in non-classical carbocation, the charge is enough to attract nucleophilic part, the nucleophile, but not that enough for rearrangement to take place. Kids, everyone, are you getting my point? My dear friends, are you able to understand now? So let me write down in non-classical carbocation, in non-classical carbonium ion charge is not that enough, for the rearrangement to take place. So my dear students, rearrangement will never take place. And let me tell you one more important point. When the rearrangement is not going to take place, Markovnikov's rule is always valid. But for that, reagent must be unsymmetrical. Now, my dear students, just see, the another bromide negative will come from the same side or opposite side. The another bromide negative will come from the opposite side. And this is known as anti-addition, my dear student. This is known as anti-addition. This is known as what? Anti-addition. Anti-addition. So whenever the non-classical carbocation is getting formed, always anti-addition is going to take place. So always keep in your brain, whenever the E part of nu is having lone pair, always the anti-addition will take place and rearrangement will never take place. This is the most important point, my dear friends. This is the most important point. You have to keep it in your brain. So from this point, what lesson you have learned, kids? The most important thing which you have learned right now, let me tell you, the enu part, whenever you are provided with this alkene RCH double bond CH2 and the enu part is there, enu kids, enu part is there, definitely this is going to attack first. If this E part is having what? If this E part is having, having what? Having lone pair or pairs, or E is mercury, then always remember that, no rearrangement case. This case is always going to be no rearrangement case, anti-addition case, It's this page is really very important. Is everyone is able to understand? Do let me know. Is everyone able to understand, my dear students? Kids, everyone is able to understand? Now, just see to it. Let me tell you one most important thing. This reaction is given in your NCERT. See to it. CH3, CH double bond CH, CH3 plus Br2 CCl4. What will you get? Simply I can write down product like this: CH3 CH Br CH Br CH3, my dear friends. Now you remember that this is active double bond and these are two chiral carbons. Here we got two chiral carbons. This compound is having two chiral carbons, my dear friends. And this will show geometrical isomerism, will show GI, that is geometrical isomerism. So the examiner will definitely ask you the stereochemistry of this reaction. Examiner's main concern will be to ask the stereochemistry of this reaction. Now let's see how the stereochemistry of this reaction will proceed. Is everyone ready, my dear students? Stereochemistry of this reaction. Is everyone ready, my dear students? Do let me know. Is everyone ready to see the stereochemistry of this reaction? Do let me know in the chat section. Are you okay or got bored? You are getting bored or okay with the same energy at which we have started, my dear students? Do let me know. Ready? Samria is ready. Very good. Now see, kids. Always remember that the thing. First of all, I will let you know the trick and then I will tell you the detail mechanism, right? Are you ready? First of all, I am going to tell you the trick and then I will let you know the whole mechanism. You remember this term, Tushar Kar CSM. You remember this, my dear students, stamp Tushar Kar CSM. Everyone, do you remember this? So if you know this thing, now see, if the examiner is going to give you question like this, see what question the examiner is going to give you. CH3, C double bond C, CH3, H. Now Br2, always remember that Br2 shows anti-addition. Right now I have told you the mechanism that Br2 will show anti-addition. So what knowledge you are going to get? See kids, what knowledge you are going to get? This is cis. So C is important. Anti, so A is important. A is important. Ca, just complete Ca. So CaR. So the answer will be racemic mixture. Answer will be racemic mixture. I hope that everyone got this trick. Everyone is able to understand this trick, my dear students. If yes, show me the thumbs up that yes, sir, we got it. We are able to understand it. Everyone, do let me know, my dear students, if you are able to understand me. Understand this concept. Show me the thumbs up, my dear students. So dextro and levo product, equimolar product. So this particular thing will give you this particular thing only, and that's why this reaction is known as stereospecific. This reaction is known as stereospecific. This is stereospecific reaction. Stereospecific reaction. Now, if I take the trans one, my dear friends, if I take the trans one, do let me know what product you are going to get. If I take trans alkene like this, this is trans, so trans T Br2 will show anti-addition. So A, I have taken A, just completed T A. So what I am supposed to write? M. If I complete T A, so I will get TAM or MAT. The meso product I am going to get, my dear students. The meso product means compound is having chiral carbons, but then also the symmetry is there, and due to that plane of symmetry, the compound has become optically inactive. Just see to it. This compound is having plane of symmetry. This is the plane of symmetry. You can see, my dear students, this is the plane of symmetry. Even though two chiral carbons are there, but then also this compound, because it has got plane of symmetry. So this is meso. Now, my dear students, this was just a trick which I have told you. Now, how many of you right now interested in knowing how this has happened, how the thing got happened, what is the reason behind it? My dear students, how many of you are able to find it out that yes, what's the reason behind it? Yeah, Sumasta, Samson, yeah, definitely. But now come back. Now try to understand. See, kids. Everyone focus over here. Everyone, you have to focus over here. Just see to it. If I take this alkene, see, kids, this is carbon, and this bond is coming towards your side. Let us suppose this is methyl. This methyl is coming towards your side, and hydrogen is going away from you, and this is double bond, one more carbon. This methyl is coming towards your side, my kids. This methyl is coming towards your side, and the hydrogen is going away from you. Can you understand? This is cis alkene. Everyone, can you understand? This is cis alkene. Yes, this is being cis alkene. Now this is p orbital and this is p orbital. If I draw it properly, my dear student, just see to it. First of all, let me tell you, this is one carbon, this is one carbon. Let me draw its p orbital, otherwise you won't be able to understand. This is one, that is one, this is one. This side we have got methyl, that side we have got hydrogen, this side we have got methyl, that side we have got hydrogen, and its p orbitals are like this. One lobe is going above the plane, it's another lobe is going down the plane, one lobe is going above the plane, another lobe is going down the plane. Are you getting my points? Everything is clear to all of you? Then that means this is the pi bond. This is the pi bond, right? This is the pi bond in between these two carbons. Can you see clearly, kids? This is the pi bond. This is the pi bond. Now, if Br2's Br is going to attack. This is Br delta positive, Br delta negative. Just to let me know on which lobe the Br is going to attack. Now, this Br plus is having four possibilities. Four. What are these four possibilities? What are these four possibilities, my dear students? These four possibilities are that this Br plus can attack over here, this Br plus can attack over here, this Br plus can attack on this carbon, this Br plus can attack on this carbon. Am I right, my dear students? Means two possibilities are from downside and two possibilities are from upsides. Dr. Addition, welcome. So this is the starting point, and with the help of this, I'm going to tell you, I'm going to explain each and everything over here. Is this clear to all of you now? See, kids, I'm going to explain each and everything. Just see to it. This is one carbon, this is another carbon. This methyl was coming towards observer side, this methyl was coming towards observer side. Both the methyls were coming towards observer side, and the hydrogen was going away from you, and the hydrogen was going away from you. Is this much clear, my dear friends? Let me write down methyl Me, hydrogens like hydrogens, hydrogens like hydrogen. So the first Br, let me attack with due permission. Where? Which carbon? You want to attack this Br from the right hand side carbon, the left hand carbon. Suppose if I have attacked this Br plus from upside. Now, my dear friends, I'm standing in front of you like this. If somebody is putting heavy box on my head, if somebody is going to put heavy box on my head, what will happen? I will go down like this, or I will go down like this. No, my nose will be coming towards your side, but I will go down like this. Are you getting my point? I will go down like this because the heavy box is on my head. Now see, this Br plus, heavy Br plus has attacked on it. Now what is going to happen? See, kids, this carbon will remain like this only. This bond will remain like this only, no problem. This is methyl will remain like this only. This is hydrogen will remain like this only. This is carbon. This methyl will shift a little bit more downside. This hydrogen will come over here, and they will give place to whom? They will give place to whom? They will give place to Br. Now Br will come over here, my dear friends. This Br positive like this, non-classical carbocation. The three-membered intermediate bromonium ion has been formed. Bromonium ion has been formed, my dear friends. Now what do you think? The another bromide will attack on the same carbon or different carbon? Yeah, different carbon, and it will come from the back side, means it will come from this side, and this is known as anti-addition. It will be responsible for anti-addition, my dear friends, right? Now, if somebody is going to lift me up, then my nose will remain in front of you, but I will go like this. If somebody is going to lift me, I will go like this. Now, this will shift a little bit. Now, see what is going to happen. You will get compound like this. Just see to it. Carbon, carbon, this methyl at this place, hydrogen over here, this bromine at this place, second bromine over here, anti-addition, this methyl at this place, right kids? Everything is correct, right thing at right time. Now this hydrogen at this place. Now my dear friends, let's find out whatever I have told you is really, I'm going to prove it or not. Just see to it, my dear friends. This was says anti-addition. What I am supposed to get? CAR, racemic mixture I am supposed to get. Now to have racemic mixture, the two chiral carbons configuration must be same. If one chiral carbon is R, another must be R. If one is S, another must be S. Otherwise it will become meso. If one is R, another one is S. So let's see what we are going to get. Let's see the first carbon. Let's apply the CIP rule. Number one, we will get to bromine. This is having maximum atomic number. Maximum atomic number. After this is least priority group because minimum atomic number. This is carbon, that is carbon. This carbon is attached with hydrogen, that carbon is attached with bromine. So number 2 should be given to that carbon, and the arrow is moving which direction? This is anti-clockwise. If the arrow is moving anti-clockwise and LPG is going away from you, that means its configuration is S configuration. This is S configuration. So it has also to come S configuration. Now let's see. Number 1 should be given to this carbon. Number 2 should be given to this carbon. Number 4 is LPG. And the arrow is going which direction? Anti-clockwise direction. Anti-clockwise direction, and hydrogen is away, that is on dash line. So this is also S configuration. Now my dear friends, you must be thinking, sir, how it is racemic? My dear friend, this bromine has attacked from the upside. If the bromine would have attacked from the downside, the another bromine must have attacked from the upside. In that case, we must have got its mirror image, that is RR configuration. So this SS and this RR, they are being racemic mixture. Being racemic mixture. I hope that everyone is able to understand, my dear friends, as proved. But in the NEET examination, the examiner is not interested in the mechanism. So everyone, you have to follow HSP Baba's trick. Which trick? Don't go for this. Everyone, if you follow this trick, HSP Baba's trick, in your examination, everyone is going to get marks. Wow, Anju Singh is liking it. That's really awesome. Priyanka Singh is also liking it. My dear friends, this trick you have to follow. Now, the question arises, The question arises, sir, oh, everyone started liking. Oh my God, thank you, my dear friends, for your huge respect and love. Wow, this is really awesome. This is really. So, everyone, smash the like button, at least make it 75, my dear friends. At least make it 75, everyone. Now, my dear friends, the question arises how that 1,2 addition product and 1,4 addition has been formed. That question you started, sir, from there, how that has formed. Seconds. Yeah, let me give you the answer of your question. Answer of your question, my dear friends. See to it now. This was the question, and from here we have started. CH2 double bond CH, CH double bond CH2, and the Br positive and Br negative, right? Delta positive, Br delta negative. Now this Br delta positive and delta negative, delta negative. Now this Br delta positive will attack, suppose, on this carbon. Now let's see by this what we are going to get. We will get compound like this. CH2 double bond CH, CH, CH2. Now this Br, that is bromonium ion, we will get bromonium ion, 3-membered ring. Now here you see rearrangement cannot take place, but the resonance will take place, my dear friends. No rearrangement, but resonance will take place. Resonance will take place. Resonance will take place. For your simplicity, let me explain. For your simplicity, for the moment of time, let me write it like this. Just to explain you, let me write it like this. CH positive, CH2, Br delta positive. Now the resonating structure will look like this. See, the resonating structure will look like this. CH2 plus CH double bond CH, CH2 Br. Now these two are resonating structure, my dear friends. One is X, one is Y. Let us suppose this resonating X, this resonating structure Y. None of them being the true structure. If I talk about true structure on the next page, I will definitely let you know the true structure on the next page. So my dear friends, what do you think, which carbocation is more stable? This carbocation is 1 degree, 1 degree. This carbocation is being 2 degree. So definitely this carbocation is more stable. Everyone, are you able to understand? This carbocation is more stable and this carbocation is less stable. Now could you please help me to know, if this carbocation is more stable, then it will be more formed, then it's more easy to attack on it. For a nucleophile, it's more easy to attack on this carbocation because this is more stable. So for the nucleophilic part, for the nucleophile, that is your Br negative, it's more easy to attack on this carbocation. Br negative can easily attack. And here the Br negative can't easily attack. Br negative can't easily attack. Till now, is it clear to all of you, my dear students? Till now, is it clear to all of you? First of all, do let me know that Br negative can easily attack, Br negative can't easily attack. Till now, is it clear to each and everyone, my dear students? Till now, this is clear to all of you? Do let me know. Everyone, do let me know. Now, my dear students, I want to see that is it till now clear to all of you? Yes. Now see, for you people, what is easy? For you people, what is easy? Just to join BSc, BA, BCom, or to qualify the entrance examination of NEET. Shiva Kumar, no break. You want break? How many of you want break? How many of you want to have break, kids? I don't think break is required. We can do it without break. Okay? Now, my dear friends, just to let me know what is easy for you to qualify or not. I'm talking about you. I'm talking like the generally the public, all the students. What's easy to get entry in the BSc, BCom, BA college, or to qualify the entrance examination of NEET? What is easy? Definitely the answer is to get entry in the BSc, BCom, like that. It's very tough. It requires lot of amount of energy, efforts, hard work, perseverance, persistence, regularity, punctuality to qualify NEET entrance examination. So to attack on this carbon, it's easy job, and to attack on this carbon is tough job. But then also most people, those who have got energy, they attack on this carbon. The one who is having potential, the regularity, the discipline, the perseverance, the punctuality, they definitely will like to go on that road which is giving success. They always see the stability. They're not seeing just the speed. You must have seen number of parents, they are telling their kids, don't waste your 1 year, just join whatever you're getting. But the students, those who are willing, those who are having those guts, they will say, no father, no mother, I will definitely, I can do this. I will and I can do this. I will qualify entrance examination of NEET, whatever the efforts I have to put. Are you getting my points? Everyone, are you getting? So, the one who is having energy, if the energy is available, energy, which ultimate source of energy, the sun energy, the heat energy. So, at higher temperature, maximum people, if the energy is available, then maximum Br negative will follow this path, and this path will give you 1,4 addition product, because this is tough path. It requires lot of energy, and if the temperature is less, maximum people will opt for this path. So it is temperature dependent. Temperature here is indicating the energy. Means if high temperature, then maximum Br negative is going to attack on this. You will get 1,4 addition. And if less heat is there, means minus 40 degree, means only few people will be able to attack over here. Rest of the people will attack on this. Now let me explain it with the help of one graph. Let me tell you the graphical representation, then you can easily understand it. See kids, let me show you the graphical representation. This is the energy. This is the energy, my dear friends, and this is the progress of reaction on x-axis. Progress of reaction. Now, my dear friends, we are going to start from here. This is the starting point, and this is the alkadine, and it is moving like this. The first step is very tough step, and it has formed intermediate. Which intermediate is this? This is Z intermediate. Now you will say, which is Z intermediate? Let me tell you, this is X, this is Y. Neither of the two were the true structure. So let me draw the resonance hybrid of these two. The resonance hybrid will look like this: CH2, CH, CH, CH2, Br, sometimes plus charge over here, sometimes plus charge over here. Single bond, double bond character, and double has partial single bond character. This is the common Wow, that's very fantastic. So this is Z common carbocation to this. The common carbocation, this is Z. Now from here, two ways are possible. The one which is going towards maximum stability. Now see, it's moving like this. It's moving like this. But its stability is fantastic. 1,4 addition, that is thermodynamically controlled product. Another will not require energy. See, it is very easy. Its activation energy is very less, but stability is very less. 1,2 addition, that is kinetically controlled product. Now my dear friends, this activation energy is common for both. This activation energy is common for both, but for 1,4 addition product, this is the activation energy required, and for 1,2 addition product, only this much activation energy is required. So which is easy job, kids? This is common path. This activation energy is common for both. Now for 1,4 addition product, this much energy is required, this much energy, but its stability is very high. And for this is like Ames Tally, that all the students, they have qualified class 12th by getting this much of energy. They have qualified class 12th. Now there are two ways. If you're getting this much of energy, if you're doing this much hard work, you are going to Ames Tally or any medical college. And if you're not doing the efforts, then it's very easy to achieve this BSc, BCom like that. But people will say, see how the people will see you, how the people will start watching you, see kids. They will say, oh, you have not done anything, because there is not too much difference. At before class 12th, you were present over here. After doing BSc, BCom, you are only up to here. But people, how the people going to see these people, they will say, oh my dear, you have really achieved a lot. You have really achieved a lot. Why they are saying like that? You have really achieved a lot, because you can see the difference. This much is the difference, and only this much is the difference. So too much difference in the reactant and products. So that much of energy they have released. For these kits, the delta H is this much, and for these kits, the delta H is only this much. So this is the difference in their stability. This is more stable job, but yes, this requires more energy, more efforts. I hope that gets. How many of you are able to understand the graphical representation? Is there anyone who got it? Is there anyone who is able to understand it? My dear students, do let me know. Is there anyone who is able to understand it? Wow, Vedha Janani got it. Super clear, Krishna. Wow. Understood. Wow, that's really awesome that these many kids are able to understand. Let me tell you addition of HOX. The third type of addition is addition of HOX. I hope that everyone is ready to understand addition of HOX. Now this HOX is known as hypohalous acid. Hypohalous acid. You must have heard the name hypohalous, halous, halic, perhalic. So like that, let me tell you, if I talk about HOF, so HOF doesn't exist at room temperature. Doesn't exist at room temperature. HOCl, it exists. HOBr, it also exists. HOI, it also exists. Now, here most of the students, they are going to do mistakes. So be careful that if I talk about this O is negative and this Cl is positive, this O is delta negative, Br is delta positive, I delta positive, and this is delta negative. In place of this, they can also give you like this Cl2 plus water. Cl2 plus water means it is going to give you HOCl. Br2 plus water, if it is given, that means HOBr. I hope that everyone is able to understand. It can be given like this, it can be given like this. So this is the E part, and E part is having lone pair. So could you please let me know, this is a rearrangement case or no rearrangement case? Everyone do let me know, this will be a rearrangement case or no rearrangement case? My question to the public is, what do you think? Is this going to be the rearrangement case or no rearrangement case, my dear friends? Let me know. This is going to be the rearrangement or no rearrangement case. So answer is no rearrangement case. Why no rearrangement case, my dear friends? Because anti-addition will take place, no rearrangement, and non-classical carbocation will be formed. Non-classical. Now one more thing, you know that this is unsymmetrical. This is being unsymmetrical. If the reactant is also unsymmetrical, then what is going to happen? Markovnikov's rule will get followed. Let me tell you, my dear friends. Suppose if I compare the reactions, just see comparative. I'm going to compare the reaction. See, just see, kids, my dear friends, just see to it. If I'm going to write it like this, CH2, CH, double bond CH2, and two types of reagents I am going to give you, my dear friend. One reagent is this, another reagent is this. In one way, I can say if I am going to react with HCl, and second way I am going to react with HOCl. Now what do you think? Is there any difference in the two reactions? Yeah. Here the product will be like this. The major product CH, CH2, CH3, you have to say whether you are agreed or not, my dear friends. I'm going to react Cl over there. Now in this case, the product, major product will be like this, CH2, CHOH, and CH2Cl. Agreed or not? For the major product, I have written two types of products. In this reaction, this is major according to me, and this is the major according to me. What you say, kids? Are you agreed or not? Yeah, I will cover each and everything. I never skip even a single thing. This is Baba HSP, and Baba HSP is not going to skip even a single thing. Do remember, then only you are going to get the rank. This is the rule of Baba HSP. Baba HSP never skip even a single thing. Now, my dear friends, are you agreed? Now, let me show you one more reaction. Let me show you one more reaction. Just see, if anyone is going to give you reactant like this. You see, this is 5-membered ring, and two types of reagents I'm going to give you. One reagent is this, one reagent is this. If the reagent is given like HCl, if the reagent is given like HOCl, what do you think? If somebody is going to ask about the major product, what do you think? This is a rearrangement case. This is a rearrangement case, and in this, the major product will be this, Cl, CH3. This is going to be a major product, my dear friends. Major, but here no ring expansion can take place because this is what? This is non-classical carbocation case. That was, the carbocation will get formed. I mean, whenever the carbocation is formed, think about rearrangement. Here, non-classical carbocation, non-classical carbocation will get formed. Are you getting my points, kids? Now, here the product will be like this. OH, CH2Cl. Everyone got it? This is 5-membered ring, that is 6-membered ring. Can you see? Everyone, can you see? Everyone, are you able to understand? Do let me know that yes, sir, we got it. I want to see more likes, kids. At least make it 75. What are you doing, my dear students? Smash the like button. At least make the like to be 75. What are you doing? What are you waiting for, my dear students? Hey, my dear students, what are you waiting for? Now see, this addition of HOX we have done. Now see, one very simple reaction I am going to give you, and just see to it. Watch it. If this is the compound given to you, CH3, CH double bond CH3. Now once they are reacting this with Br2, CCl4, another time they are going to react it with Br2 water. Can you find any difference in the two reactions? In these two reactions, can you find any difference? So definitely the difference is there. There is Br2, that means only Br2 is there. That means the product will be CHBr, CH2, Br. But if I talk about this reaction, that means this is doing equilibrium with HOBr. So two types of products you will get. One product will be like this, CH3, CHBr, CH2Br, and second product will be like this, CH3, CHOH, CH2Br. My dear students, that's why you must have seen whenever you are going to add Br2, number of times Br2CCl4 must be written over there. That's why the CCl4 is non-polar solvent. That only addition of Br2 will take place. But if you are taking water, then two types of nucleophiles are there. Electrophile is common. In this also, the electrophile is Br plus. Here also the electrophile is Br plus. But in this reaction, the nucleophile is Br negative only. Here the nucleophilic part is Br negative only. And here the nucleophile is OH negative, and Br negative. Can you see? Br negative. So two types of nucleophiles are present over here, my dear student. That's why you are getting such type of reaction. Now, only addition of water is left. I told you the addition of HX. I told you the addition of X2. I told you the addition of hypohalocyanide acid, that is HOX. Just now, only one thing is left, that is addition of water. So is everyone ready? Is everyone full on Josh? Kids, do let me know that you are ready. I want to see the Josh. Everyone's Josh. Kids, do let me know. Is everyone ready? Wow, everyone is ready, my dear friends. That's really awesome. Now, addition of water. There are three things in addition of water. Really important. This addition of water is very, very important. Why it is important? Let me tell you. Number of times we have removed water. Now we are going to add water. Addition of water. In this addition of water, we are going to see three type of things. 1, 2, and 3. First one is acidic hydration. We will say acidic hydration. Second one, we will say OMDM reaction, Oxymercuration-Demercuration. Third is HBO, brown hydroboration. And it really holds a lot of weightage. It's really going to be very, very important, my dear friends. So let's see to it. So first one, acidic hydration. This is inferior quality because mixture of alcohols is obtained. Mixture of alcohol. These two are no rearrangement case. These two are what? These two are being no rearrangement case. We will understand why no rearrangement case. It will follow Markovnikov's addition. It follows Markovnikov's. I will let you know why. and it will follow anti-Markovnikov addition. Anti-Markovnikov addition. Now, let's understand each and everything one by one. So let's deal with acidic hydration, and whenever we are going to deal with acidic hydration, I'm not going to tell you even a single thing. Only you have to understand by yourself. Acidic hydration, kids. Now it's time to apply your brain. That let me take one beaker of flask, and in this let me take one ethene or propene, whatever you want to say. Let us take propene, right? And second one, let me take water in presence of H2SO4. These three type of entities are present over here. These are the three type of entities. My dear students, do let me know, out of these three type of entities, which entity is going to release something very fastly? Which entity out of these three is going to release whatever it wants to release? Which one is going to react fastly? The answer is H2SO4. H2SO4 has got the habit of just donating proton. Am I right? Am I right, my dear friends? If you would have been in my place, you would have also said that, yes, sir, you're right, absolutely correct. Now, this H plus will attack on this alkene or water. Just see, alkene, if I write alkene, the alkenes carbons electronegativity is how much? Alkenes carbons electronegativity is 2.75 because it is sp2 hybridized, and H2O's oxygen's electronegativity is 3.5. So what it is easy to attack on which? This carbon or this oxygen? This is more electronegative, so it's tough to attack on this oxygen. So it's easy for this H plus ion to attack on this alkene, and it will attack on this carbon, because if it is going to attack on this carbon, you will get more stable carbocation. Up to this place, up to now, till now, everyone, can you apply your brain? For how many days you are going to be dependent on your teacher or on your book? How many times you are going to revise? Kids, it's a time that you have to show your intelligence, that you are going to make reaction from your side. You need not to wait for anyone. You need not to be dependent on any book. Now you have to become scientist. This is the time. Now this is the time when you have to show that, yes, I'm having that much brain that I can apply. Now see, kids, this is the scenario, this is the scene, how the things are going to take place. Now this H plus will attack on this. Now let's see what is going to happen on another page. So this is your alkene, and on this alkene, what do you think? The H plus will attack on this carbon major, but this carbon less amount. But yes, H plus will definitely attack on both the carbons, but this will be minor and that will be major. Agreed? So you are going to get two types of carbocations. In this case, one carbocation will be like this, CH3, CH plus, CH3, and second carbocation will be like CH3, CH2, CH2 plus. Now, once this carbocation, two carbocations are formed, water will come. Now water is saying, hey, I have got electrons, I'm rich, I'm richy rich. So carbon will say, oh my dear, you have got 8 electrons and I'm just with 6 electrons. I'm electrophile and you are being nucleophile, and the electrophile, you are being the nucleophile. Just come over here. I need you, I need you, I need you right now. Now they will form bond. See what type of bonding is going to take place, my dear students. They are going to form oxonium ion. This will form oxonium ion like this, CH. O positive, H2 white plus charge on oxygen, because oxygen has donated 1 electron to this carbon. After donating, it has got 7 electrons. It has also got 7 electrons, 7 7 they got formed. Now they are having 8 8. Now kids must be thinking, how 8 when that has donated 1 electron, then how 8? Kids, after donating this electron, it has shared. Now it is just making bond with that, because the electron was of oxygen. So this is oxonium ion. Here also this is being oxonium ion. CH3, CH2, CH2, O positive H2. All these two are being oxonium ions. And at last they will remove their proton. They will remove their proton and they will form stable product like this, isopropyl alcohol and propanol. Have you got this answer, everyone, kids? You got it by yourself, or I have written, that's why you got? Wow, that's really awesome, Vedha Janani, Krishna, that they have got product and you people got product by yourself. So you can see mixture of alcohol is obtained. Mixture of alcohol is obtained. Now, for example, if you're getting this reactant, just see to it. If somebody is going to give you alkene like this, if this alkene has been provided and they have given water in acidic medium, suppose they have given water in acidic medium, what do you think, what products you are going to write down over there? So you have to move step by step, then only you can find out the answer, otherwise not. See, first of all, this H2SO4 will release H plus, and that is going to attack over here. When it is going to attack, my dear student, you will get compound like this. Now whenever the carbocation is getting formed, always think about rearrangement. So here ring expansion will take place, and this ring expansion already I have told you how to do it. This bond will break from here, delta positive, delta negative, and it will start forming bond at this carbon. So very soon you are going to get carbocation like this plus charge, this, and this. They have formed the bond, positive charge over here. This is just the newly formed bond. This is this bond, newly formed bond. Can you see? Can you understand? And this CH3 at this place. Either you can write like this, or you can write the same compound like this, plus charge, and this is being CH3. Now this ring has expanded and you got 6-membered ring, but one problem is there. This hydrogen is saying, if I move along with my electron at this place 1 to hydride shift, then definitely it will be better. Now 1 to hydride shift will take place and you will get the most stable carbocation. This is going to be your most stable carbocation. Now my dear friends, the plus charge is over here on the same carbon. Now my dear students, how many types of carbocations you got? 1. This is same. Either you can write like this or this. 1, 2, 3. Which one 3? This 1. Let me write down, otherwise you will forget. A, ring expansion. B, C. One more carbocation you will get, but that I will let you know later on. but this is going to form the major product, because examiner is always interested in major products. So my dear students, you got this as the major product. Is that clear to each and everyone? So this was acidic hydration, 1-methyl cyclohexanol with hydrogen rats. Really fantastic. Great, great. Now my dear students, I'm going to explain oxymercuration-demercuration and then HBO. These are the two reactions. After that, the lecture will get completed. Are you ready, my dear students? First of all, have a glass of water. Everyone, have a glass of water. Everyone, feel hydrated. Keep hydrated yourself for a long race, because the journey is very, yes, long. So we have to keep ourselves hydrated. If you have got fruits, then you can eat. Right now the sunlight is not there, so no need to eat fruits, but yes, you can. My dear students, let's start oxymercuration-demercuration, right? Oxymercuration-demercuration. I hope that everyone is ready for oxymercuration-demercuration. Oxymercuration-demercuration. In shortcut, people call it OM-DM reaction. OM-DM reaction. So one thing is very, very famous about this reaction, my dear friend, that in this we will get pure alcohol. That is the most important thing. Its product is being pure alcohol. Pure alcohol is obtained. That is the most important thing. And purity matters a lot. Pure alcohol is the product. This is the most important thing. So let's see what is going to happen, that we are going to get pure product. Pure alcohol is the product. No mixture is there. Second thing, Markovnikov's rule is followed. Markovnikov. Now let's see why always Markovnikov's rule will be followed. So these are the points. And one more thing is that the intermediate is known as mercurinium ion. Which intermediate, my dear friends? Which intermediate? Here, the intermediate is mercurinium ion. Mercurinium ion is the intermediate. This is being the intermediate. So these the points which we are supposed to understand, and we have to follow it. Now see what is the reaction. The reaction over here is, let us suppose we are going to take CH3, CH double bond CH2. The most important thing is the reagent. This is the most important thing, and always try to remember it, what the reagent is there, my dear friends, because this is very, very important. First is mercuric acetate, that is CH3 COO whole twice mercury plus THF plus water, THF plus water, THF plus water. Once all these things got reacted, then we will add NaBH4 OH negative. So first these reagents we are going to add, and after that these reagents we are going to add, and then we will get pure alcohol, CH3, CHOH, CH3. This is the pure product. Now, my dear friends, this is mercuric acetate, and in your examination, this mercuric acetate can be given in how many ways? That is the most important point. This mercuric acetate is like this: CH3, C double bond O, OHG, O, C double bond O, CH3. Now, my dear friends, for this much part, AC can be written AC, acetyl. So it can also be given like this: AC, O, HG, O, AC. Can you see, my dear students? Mercuric acetate can be given in any way. So now it's the point to think about the mechanism, how this reaction is going to take place. What is the mechanism? Wow, Buddha Surya, welcome. Shakti Ganesh is there. Wow, Shakti, that's really awesome, my dear students. These are the students who are gem in chemistry. Welcome, Khan, Sania, Shakti Ganesh, Buddha Surya, really heart-touching. They have completed their one class, physics class, and after Shakti Ganesh has done the physics class, now Shakti Ganesh is with this chemistry class, and Buddha Surya was suffering with fever. Now he is back. Wow. This is Khan, Sania, this is 12th chemistry. This is 12th chemistry only. Now let's see the mechanism. What's the mechanism they are going to follow? That holds a whole lot of weightage. So everyone ready to see the mechanism? Are you ready, my dear friends? What mechanism they are going to follow? Just see to it. See, everyone. This is mercuric acetate, CH3, C double bond O, OHG, O, C double bond O, CH3. You know, mercury is a metal. Yeah, Buddha Surya, good. Krishna, good. Mercury is a metal, but liquid in nature. Special type of metal. Now, mercury said, hey, oxygen, I'm going. I want to leave you. Let me go. I gotta go. Let me go. Oxygen is saying, hey, mercury, where are you going? You are going to leave me? Who is there? Where are you going? So mercury said, I'm going to alkene. So oxygen started thinking, what's there? Why the mercury is going to that carbon? So my dear friends, see, the oxygen's electronegativity is 3.5, but this carbon's electronegativity is just 2.75. So mercury thought it's better to live with carbon. Mercury thought it's better to live with carbon because carbon is being less electronegative, so I will feel better. So mercury started moving to that carbon, and mercury is saying, hey carbon, I want to join you. I want to come to your life. So mercury has attacked this carbon. Actually, mercury is not loving carbon. Mercury is loving this electron. You know, your HSP Baba always treat electron like money and atoms like human beings. This carbon is thinking that mercury is loving me. That carbon is thinking that mercury loves me. But mercury was having something else in his or in her brain. Mercury was loving electron, not the carbon. Mercury was just interested in the electrons, not these carbons. Now see what the story and how the story is going to move, My dear friends, are you able to understand what I'm telling you? Now see kids, the story will move like this. CH2, CH, CH3 and mercury will come in the life of both. Both started thinking, oh, mercury is mine, mercury is mine. But you know, mercury is just interested in the electron. In this way, three-membered intermediate mercuranium ion has been formed. Three-membered intermediate mercuranium ion has been formed. Now, my dear friends, after this, the water will come from the opposite side. Water will attack from the opposite side. So we will say this is anti-addition. This is also going to be the anti-addition. So you will get compound like this. Now kids, on this carbon or that carbon, which carbon this water will attack, let me show you. And that is the important thing. This carbon is 1 degree carbocation and this carbon is 2 degree carbocation. This will attack here for minor because this is the less stable carbocation, and this will attack there for major because that is being more stable, not the pure carbocation, but yeah, little bit charge is there. So mercury will stay with this carbon. Mercury will stay with this carbon, HgO, CO, CH3, and water will come over there like OH because its proton will get eliminated out, and this will be the CH3. Now, my dear students, till now this was oxymercuration. Till now this is oxymercuration. Now, in number of steps, demercuration will take place. Those steps are not in your syllabus. In number of steps, when you are going to add NaBH4, OH negative, number of steps, demercuration will take place and your product has been formed like CH3, CH, OH, CH3. So remember that in this reaction, thank you Priyanka Singh ji, Sarvesh Sharma ji, in this reaction, no rearrangement will take place and the reaction will move like this. Now, if same reaction is going to take place with alkyne, let's see how the reaction will take place, kids. This is acetylene, and you know that alkynes are less reactive towards water. So the examiner will give you like this. The reaction will proceed like this. Water, 1% HgSO4, 40% H2SO4. What should be the product? The examiner will ask like this, my dear friends. Now let's see how to do it. You can see one side H plus will added and another side OH negative will be added, and this is enol, you know very well. And in this enol form, tautomerization will take place. 1, 2, 3. From first atom, hydrogen will go to the third atom and double bond will come in between 1 and 2. So the tautomerization form will be more towards that direction and you will get CH3, CH double bond O, 99% this is stable, 1% is this stable enolic form, and that is being keto form, and these are the tautomers. Now my dear friends, in the examination you won't get this much of time. How many of you want that to solve this reaction within fraction of seconds without doing tautomerism? Without showing the tautomerization, how many of you want to do this reaction within fraction of seconds without doing tautomerization? My dear friends, how many of you want? Now see how to do this reaction within fraction of seconds. Just see to it, everyone. As I have told you, no rearrangement will take place. Markovnikov's rule will be followed, and Markovnikov's rule says that negative part of the reagent goes to that carbon which has less number of hydrogen atoms. This is not having hydrogen, that is having one hydrogen. You can see this negative part will come to this carbon and the positive part will attack over there. So see, you can see the product within fraction of seconds. CH3, C double bond O, CH3. Any reaction you can do, any type of question, it is valid everywhere for all the questions. It will not get failed in any question. For example, if you do reaction, this reaction, you just apply your brain. What to do, my dear students? See, Markovnikov's rule, O, H, H. What you're supposed to do, my dear students? Give oxygen to this, give hydrogens to this, and you will get product like this. My dear students, is everyone able to understand? Do let me know. You will get acetophenol. It's clear to all of you? Is it helping? I will let you know. Buddha Surya, the anti-Markovnikov's rule also I will let you know. But first of all, everyone do let me know that are you able to understand these questions? Can you solve these questions within fraction of seconds? Now after this, I'm going to tell you the last topic of today, that is Brown hydroboration. But before that, everyone make it 85. Likes are 78. Let's see how many of you can put or hit or smash the like button to make it 85. How fast? But okay, let me tell you once more. Don't worry, but see, if examiner is going to give you a question like this, but everyone see to it. Suppose this is the question. CH3, CH2, C triple bond CH. What your Markovnikov's rule says, that negative part of the reagent will go to that carbon which has less number of hydrogen. So it is having one hydrogen, it is not having any hydrogen. So this is having less. So the negative part of water, you know, waters, this is being delta positive, and this is being negative, negative. This part will come to this carbon. So it will attach over here and these two hydrogens are going to form a bond over there. I hope but you got it. Everyone is able to understand, my dear students. So what answer you are going to get? CH3, CH2, C, CH. So two hydrogens will attach over here and the oxygen part will come to this place. I hope that everyone is able to understand. Wow, that's really awesome. Buddha Surya, really good. Butane 2-1. Yeah, Vedha Janini, this is correct. Now, let's deal with reaction known as what? Which reaction, kids? Do let me know which reaction I'm going to talk about. Definitely Brown hydroboration-oxidation. Brown hydroboration oxidation. Brown hydroboration-oxidation reaction, that is your HBO reaction. Very famous reaction. HBO reaction. Now let's see what is going to happen over here. Same, let us take CH3, CH double bond CH2, is going to react with the special reagents. These reagents are very, very important. BH3 or B2H6 you can use, plus THF. THF is tetrahydrofuran solvent plus H2O. The first, once this has been reacted, then you are supposed to use H2O2 OH negative. A pure alcohol you will get. That is following anti-Markovnikov's rule, CH3, CH2, CH2OH. That negative part of the reagent will go to that carbon which is having more hydrogen atoms, opposite to Markovnikov's rule. In Markovnikov's rule, the negative part was going to that carbon which was having less number of hydrogen atoms, but here more number of hydrogen atoms. This is pure alcohol. Now, my dear students, in place of BH3, B2H6 can be used. Some more reagents can be used, but they are not in our syllabus, so don't get confused if somebody at some place it's given like SiO2BH, SiA2BH can be used, or N9BBN can also be used in place of what? In place of BH3, but they are not in our syllabus, not required, not in syllabus. Now let's see, kids, how this reaction takes place. What is the thing which is responsible for this reaction to give anti-Markovnikov's addition? Because you must be thinking, whenever I'm going to write anti-Markovnikov's rule, you must be thinking Kharas effect, you must be thinking about benzoyl peroxide, blah blah blah, and that takes place in HBr peroxide and symmetrical reactant, but it's not like this. Here is something new thing is there. Just try to understand. See, kids. So if I write your CH3, CH double bond CH2 and BH3, just see to it. BH3 is being electron deficient because only 6 electrons are there in the outermost shell of boron. So it is electrophile, the Lewis acid. Electrophile, Lewis acid. Now, my dear friend, why THF is used? Let me tell you why THF is used. THF means kids, tetrahydrofuran. THF means solvent tetrahydrofuran. Tetrahydrofuran. Now, my dear friends, THF looks like this. This is your THF. Okay. You know furan is aromatic, and if you add 4 hydrogen atoms in furan, you will get tetrahydrofuran. Now, this furan is having lone pair, and this is a nucleophilic part, and this is giving support through its coordinate bond to BH3, so that it should not dimerize to B2H6. So that's why the solvent is used. But anyways, let's come to the reaction. This is having pi electrons, so this is being nucleophilic. First of all, we have to understand what the things are given over there. This is being nucleophilic and that is being electrophilic. So definitely the electrophile is going to attack on nucleophile. Till now, I hope that everyone is able to understand how the reaction is going to proceed and why the things are added and why the things are like this and why it is given and what's the role of this solvent. So solvent, by solvent is used, solvent, the role of solvent, and this is your solvent. Why solvent is kept over there, that is also given over there. My dear students, is everyone? Now let's see the reaction on next page, how this is going to take place. Everyone see to it. So this is your reactant CH3, CH double bond CH2, and BH3 is going to attack on it, boron. Now why boron only on this carbon is going to attack? There is a reason. This is alkyl group. This is showing plus I inductive effect and it is donating electrons. So this electron is shifting toward this side. There is negative and there is delta positive. So this electron deficient is going to attracted by this negative charge. Now let's see what is going to happen, my dear friends. So the reaction will proceed like this. CH3, CH positive, CH2 negative. Thus, for a better understanding, I am drawing it like this because this is just for understanding. Now, see kids, it is right now having 8 electrons. It is having just 6 electrons. So, they will start forming bond. After some time, you will see it like this. CH3, CH positive, CH2. Now boron will take or snatch one electron from carbon. When this boron is going to snatch one electron from this carbon, boron will have 7 electrons along with negative charge, and that carbon will become neutral along with 7 electrons. 7 7 they will form one new bond. Now it will look like this, BH3 negative. Now my dear friends, boron is very small atom. Boron belongs to second period. So boron cannot manage 4 valencies. So very soon boron has realized that I cannot manage these 4 valencies. So what he has started doing, see kids, in the next step, I'm moving very slowly so that you can understand each and everything, because all these steps, they are taking place very fast, but I'm making it a slow motion so that my all dear students can understand it properly. BH2 and one hydrogen will go over here and it will start forming bond on this carbon, kids. Now first time you have seen that 4-membered intermediate is getting formed. Till now we have seen the 3-membered intermediate, but this is the first time the 4-membered intermediate is getting formed. 4-membered intermediate. And one more special thing has happened. 4-membered intermediate is getting formed. One more very special thing has happened, that syn addition from site, the site from which the boron is getting attacked, same site this hydrogen is also getting added. Syn addition, this is the first time syn addition took place. Till now you have seen anti addition was taking place. Syn addition, now how it will look like, let's see on the next page so that we can understand in a better way. Now see, my dear friends, after some time it will look like this. CH3, CH2, boron with 2 hydrogens, and what hydrogen has been added over here. Till now everyone is able to understand? Do let me know, my dear friends. Till now each and everything you are able to understand. Now boron is feeling really very happy. Boron is really feeling very happy. Now see why boron is feeling happy, my dear friends. What's the reason why boron is feeling happy? This alkyl group is electron donating. This is donating electron donor, and boron was in need of electron. So my dear friends, electron donating group, because of plus I, boron is very happy, and boron told mother, hey mother, I'm very happy. Mother was saying, why you are happy? What has happened? Why you are feeling happy? Boron said, Mama, the one with whom I have been bonded is rich. That entity is providing electron to me. Mama said, oh my dear kid, what are you waiting for? Whatever you have done once, do it twice more. Just donate these hydrogens and attack on rest of other two propenes. What are you waiting for, my dear kid? Just go and attack on two more propenes. So my dear students, if examiner is asking who is required in major amount, who is required in more amount, so remember that one boron can kill 3 propene. So 1 BH3, the ratio is BH3 if we require 1, then propene we will require, or alkene we will require 3 moles. 1:3 ratio is required. Is everyone able to understand, my dear student, this point? If the ratio examiner is going to ask, you should know. Now after reaction, see what they are going to form. Just see to it and look over here. So boron will get attached to 3 alkyl groups, and boron will look like this. See kids, how the boron will look like after some time. Boron 1, 2, 3. CH2, CH2, CH3, CH2, CH2, CH3, CH2, CH2, CH3. This is intermediate. Intermediate's name is trialkyl borane. What is the name? Trialkyl borane. Remember that. They can ask you the intermediate. This is intermediate name is trialkyl borane. Trialkyl borane. My dear students, till now everyone got it. Trialkyl borane is the intermediate. Now my dear student, after this step, after the formation of trialkyl borane, what you are going to get? See to it kids. You got CH3, CH2, CH2, whole thrice B. This is your trialkyl borane. Now it will react in number of steps. They are not in its syllabus, my dear students, not even the syllabus of IIT. Multi-step reaction. Multi-step reaction with H2O2 OH negative. This will eliminate out and you will get 3 moles of CH3, CH2, CH2, OH plus H3BO3 carom board powder, that is boric acid. My dear friends, let me tell you here one thing, one important thing. If this is going to react with acid, one carboxylic acid, any carboxylic acid, if it is going to react, then this is known as reductive hydroboration. This will be known as reductive hydroboration. And in reductive hydroboration, you will get CH3, CH2, CH2H. Alkane will be the product, not the alcohol. The product will be alkane. Now, my dear students, just 5 minutes more. Are you ready? Just 5 minutes more. Okay, my dear students. Now, the question arises that the same reaction is going to happen with alkynes. The same reaction is going to happen with alkyne. What should be the answer? Now, see, it's the same reaction is going to happen with alkynes. Just see, If anyone is going to give you reactant like this, CH3, C triple bond CH, and they are going to do brown hydroboration oxidation. So they have given you the reagent like this, B2H6, THF, water, second is H2O2 OH negative. One way is that you can go with addition of water, anti-Markovnikov's rule. The negative part of the reagent will go to that double bonded carbon or triple bonded carbon which has more number of hydrogen atoms. You will get enol, then you can tautomerize. Or you can apply Baba HSP's rule, because no rearrangement is going to take place. You can directly get the answer that you apply anti-Markovnikov. What you have done, yes, what you did in Markovnikov's rule, just opposite to that you can do. Now you see what product you are going to get. Give oxygen to this, to hydrogen to this, and directly on the spot you will get the answer CH3 CH2 CH double bond O. Now my dear student, how this is different from OM-DM reaction, just see, let's compare, and then you will find out something. I'm going to give you 6 examples, just compare and try to find out. Okay, first example, CH triple bond CH. Second example, CH3 C triple bond C CH3. Now I'm going to do reaction. One OM-DM reaction, one HBO reaction, one OM-DM reaction, one HBO reaction. Just try to find out whether the same answer you are going to get or different. OM-DM reaction, HBO reaction, OM-DM reaction, HBO reaction. Just do let me know speedily that in the first reaction, whether you do OM-DM or HBO, the answer is coming same. Here also, whether you do OM-DM reaction or HBO reaction, answer is coming same or not, kids? Definitely. Here the answer in both the two cases is CH3 CHO, and here in both the cases answer is being like this. Kids, is it correct? If you are able to do it. Now kids, after doing this, if I give you a reactant like this, just see to it, CH3 C triple bond CH. Now once if I am going to do OM-DM reaction and once I am going to do HBO reaction, what do you think? Same answer or different answer you are going to get? Now this time you are going to get same answer or different answer. Do let me know, my dear friends. So definitely your answer will be sir. Here we are getting acetone. Here we are getting aldehyde. Now we can also say that in OM-DM reaction we will always get ketone except acetylene. If we just leave the case of acetylene, we will always get OM-DM reaction. We will get ketone in OM-DM reaction. Just acetylene is going to give you aldehyde in OM-DM reaction. Otherwise, we will always get what? Ketone. Now, last but not the least, just see this reaction. This is rank deciding question. It can be because it's not given in NCERT. Rank deciding. If they are going to ask question like this, that we are provided with CH3 C triple bond CH, BH3 EHF, water, and acetic acid or carboxylic acid. Now, what is the product? My dear students, what will be the product? Now you can see the first how to solve it. This was the question, my dear students. And let's find out the answer. First, you know that the intermediate will form what intermediate? CH3, CH double bond. No, this will, the BH3 will attack on this, we will get H. This will remain CH whole thrice B. Now here the intermediate is trialkynyl borane. Kids, there it was trialkyl borane. Here trialkynyl borane. Now this trialkynyl borane on reaction with RCOH, reductive brown hydroboration, so you'll get 3 moles of CH3 CH double bond CH2. So here alkene will be the product, my dear friends. So this reaction becomes important because it is not given in NCERT. My dear friends, I hope that everyone is able to understand. Is that clear to all of you? As I have told you, no need of break is there. Continuously for 2.5 hours we have studied. Credit goes to both of us that I was teaching continuously and you were studying continuously. One student, Shakti Ganesh, after completing the physics lecture, this student was over here. One is Buddha Surya. Although he was suffering with fever, but he must be thinking that he's missing his class. Once he's recovered and he's back. Your performance is really very good, but take care of your health too. Buddha Surya, I would like to say that health is wealth and health is first. In a healthy body, the healthy mind remains. Okay, my dear students, resides, you know that healthy mind resides in a healthy body only, and that reminds about the brain's mind memory, the number of things, so you can recall the things and you can do all the questions. Bye to all of you. Samriya, Krishna, Vedhajanani, all my dear students. Let me complete all these type of reactions first, then I will complete name reactions in detail. Name reactions I would like to give you in detail, my dear students. After completing name reactions, I will complete reagents. Then we will do number of questions based on name reactions and reagents, my dear students. You know that I never do any partiality. Wherever any student is studying, I always give you quality kits. It's not like other YT channels. We are Unacademy NEET English channel. We cannot compromise with the quality. My dear friends, bye to all of you. God bless you. Love you. Bye, my dear friends. Take care.